Let's talk about magnets. We've all played with them, right? That satisfying snap when they stick to the fridge. They seem so simple. But then you get to physics class.
And all of a sudden, it's not so simple anymore. It's all about magnetic fields and flux and these weird right-hand rules that seem designed to tie your brain in a knot. And if you've ever felt that confusion, trust me, you are definitely not alone. It's one of the most common stumbling blocks. And a huge part of the problem is this. You open a textbook and you see these diagrams with all these dotted lines looping all over the place. You're just supposed to look at it and get it. But what even are those lines? Why do they go where they go? Well, here's the thing. It all boils down to one single fundamental problem. That's it. That's the whole issue. Our brains are amazing, but they have a really tough time wrapping around concepts we can't see. You know, you can watch a ball fall and understand gravity, but you can't see a magnetic field. So that's what we're going to do today. We are going to make the invisible visible. All right, so let's get right into it. If you want to really understand magnetism, you have to be able to build a mental picture of what's happening. And the key to that picture is something we call a magnetic field. So, what is a magnetic field? Think about it this way. Imagine you're at a party, and there's that one person who's super charismatic, the center of attention. They have this energy around them, right? An aura that kind of influences the whole room. That region of influence is exactly what a magnetic field is. It's just the space around a magnet where its force can be felt. Okay, so how do we see this invisible energy? Well, physicists came up with a really clever tool. These imaginary things called magnetic field lines. Now, they're not actually lines floating in space. It's kind of like your Wi-Fi signal. You can't see it, but, it's there. These lines are just our way of drawing a map of that invisible field. Now, listen carefully, because here's the secret. To solve almost any problem in magnetism, you don't need to memorize dozens of equations. You just need to know just four simple rules that these imaginary lines have to follow. Think of this as the rule book for how magnetism works. Let me break these down because this is absolutely crucial. Rule number 1, magnetic field lines always form closed loops. They leave the North Pole, they loop around into the South Pole, and this is the part people forget, they continue through the magnet back to the north. Rule 2, they never ever cross each other. Think about it, the field can only point in one direction at any given spot. Rule 3, this one's easy. Where the lines are packed close together, the field is strong. Where they're spread far apart, the field is weak. Density equals strength. And finally, Rule 4, the direction an arrow on the line is pointing, well, that is the direction of the magnetic field right there. If you can lock in these 4 rules, you're halfway there. So what does this mean for you? It means we can now use these rules to actually see what the field looks like for different magnets and wires. Let's look at a few of the most common patterns you'll run into. First up, the old classic bar magnet. You can see the lines bursting out from the North Pole. See how dense they are right there? That's rule number 3 in action. It's where the field is strongest. Then they curve all the way around and enter the South Pole, where they're packed together again. It's a perfect visual for why a magnet's pole is always strongest right at the poles. Okay, now for something that's really kind of mind-blowing. It's not just magnets that make magnetic fields. A moving electric charge, what we just call a current, does it too. And if you have a current flowing through a perfectly straight wire, the magnetic field lines it creates are perfect circles wrapping around the wire. That leads to the obvious question, right? Are the circles spinning clockwise, or are they going counterclockwise? Guessing is a 50-50 shot, and that's not good enough in physics. Thankfully, there is a super simple trick to get it right every single time. And it's called the right-hand thumb rule. No, seriously, do this with me right now, wherever you are. Take your right hand, point your thumb in the same direction the current is flowing. Now, just let your fingers curl naturally. That direction your fingers are curling, that is the exact direction of the magnetic field. It's like a built-in cheat code that you always have with you. So what happens if we take that wire and instead of keeping it straight, we coil it up really tightly like a spring? We call that a solenoid, and something really cool happens. Inside the coil, those circular fields all add up to create magnetic field lines that are almost perfectly straight and evenly spaced. This gives us a beautiful, uniform magnetic field, which is incredibly useful in technology. And on the outside, it acts just like a really powerful bar magnet. You know what's really interesting? This whole closed loop thing for magnets points to a really deep truth about how our universe works. Electric field lines are different. They can start on a positive charge and just end on a negative one. But magnetic lines have to loop back on themselves. Why?
Well, it's because you can have a positive charge all by itself, or a negative charge, but you can never, ever have a north pole without a south pole attached. If you cut a magnet in half, you don't get a separate north and south, you just get two smaller magnets. This idea that there are no single magnetic poles or monopoles is a fundamental law of physics.
Okay, so we've gone through the core idea, the four golden rules, and the most common patterns. So how do you make this all stick? How do you actually use this to get the right answers? Here's your simple go-to action plan. This is it. This is your takeaway. Number one, always start by visualizing the lines. Just remember, they're closed loops, and how close they are tells you how strong the field is. Number two, use your hand. Don't be shy about it. The right-hand rule is your best friend for figuring out direction. And number three, and this might be the most important tip of all, before you even think about numbers or equations, draw it out. Just a quick sketch of the wire, the magnet, and the field lines. This one habit will save you from so many simple mistakes.
So we started this whole thing by saying that magnetism is tough because it's invisible. But hopefully you see now that by using these tools, the field lines, the rules, and your own hand, you can actually learn to see it. So I'll leave you with this question. Now that you have a strategy for visualizing something you can't see, what other concept in physics, or anything else, feels impossible to picture? Because this same approach of finding the right visual model might just be the key to unlocking that too.